Hi everyone, it's Miss H, and this is going to be our final video on waves. And this video is going to be on wave interactions. So the first wave interaction we want to talk about is interference. With interference, you have two forms. When you have constructive interference, you have two crests or two troughs that collide, resulting in a larger amplitude. So if you have one wave is going this way, and the other wave is going this way, then when they come together, okay, your amplitude increases, and then they continue moving as they were. So in this case, since both waves have the same amplitude, you'd have double the amplitude, and my middle one is a little bit off on size, but it just kind of gives you the idea that the amplitude did in fact increase. It shouldn't have been so much wider. But that kind of just gives you a general idea of what constructive interference is. Constructive, you build up when the two waves, when the two crests or two troughs collide, the amplitude increases. The other form of interference is destructive interference. With destructive interference, you have a crest and a trough colliding, resulting in a smaller amplitude. So again, this time I have my crest going one way and my trough going the other. So when they come together, if the amplitudes are the exact same, you'll end up with a flat line. If the amplitudes are not exactly the same, you'll end up with a smaller amplitude. And then they continue on in the same direction they were going before. It's a little easier to see this with destructive interference because of the fact that the crest and trough are on opposite sides. So it's important to note that with interference, that the crest and troughs move through each other. They do not bounce off of each other. If they bounced off of each other, we would never actually be able to see or hear anything. We'd constantly be having to deal with you're trying to talk at the same time as somebody else, and you wouldn't be able to hear them because they're trying, you would only hear yourself and they would only hear them because your waves are hitting each other and bouncing back. And we know that that's not the case. We can still hear other people even if we don't necessarily listen to them. We can hear the other person when they're talking at the same time as us. We just, because our waves pass through each other. Okay. The second type of wave interaction we want to look at is what happens when light hits a new medium. And this is similar to what happens with sound as well, but we're going to focus on what happens with light. So one of three things can happen when light hits a new medium. The first is that it can be absorbed. So with absorption, the energy is taken into the substance, and this typically causes an increase in temperature. So when the sunlight comes through the window and it hits the table heats up. It's the same concept. The sunlight gets absorbed by your car interior, and that's why it burns your hand when you go to touch the steering wheel. Most of the materials that we encounter in our everyday lives are actually opaque. Opaque means that they do not allow the light to pass through, and if the light cannot pass through, it's typically absorbed. The second thing that can happen is transmission. So when transmission occurs, the light is allowed to pass through the substance. So think about light passing through a window or a glass of water. Okay. Refraction occurs when the light bends as it enters a new medium because it changes speed. So with refraction, you have something like here is air, and here is water. And so when the light comes in at one angle, it then changes to a different angle because of the difference in densities, difference in the materials, and so it changes speeds. So that's refraction. It's the bending of light because it changes speeds as it enters a new medium. Most materials that transmit light are either transparent, like clear glass, and allow all of the light to pass through, or they are translucent, which allows only some of the light to pass through. So think about like smoky glass or fog. You can see the outline of the person on the other side, but you can't see any details. Whereas regular glass, even if it's like blue or red or any other color, if it's just a plain glass, you can actually see the person on the other side. You can tell where their eyes are, their mouth is. You can tell what their hands are doing. You can actually see the details of the person, see the pattern on their shirt, that sort of thing. But with a translucent material, you wouldn't be able to see that. If you put up a flashlight behind a translucent material, you can see the light kind of diffuses out. It doesn't come straight through as a beam, whereas if you put it behind a transparent material, the beam would actually come through. Okay, the final thing that can happen when light hits a new medium is that it can bounce back. So when light bounces back, it does so in one of two ways. The first is reflection, and with reflection, the light comes in and bounces back at the same angle. So the angle in we call the angle of incidence, the angle out we call the angle of reflection, and these two angles are actually going to be equal to each other. This typically happens when the surface is very smooth or shiny, like a mirror, or the flat surface of a lake that's calm, anything where the light comes in and out at the same angle. The other thing that you can have is you can have diffraction. So with diffraction, your surface that you're hitting typically isn't as smooth, and so the light comes in. That again. The light comes in at one angle, but because the surface isn't smooth, it bounces back at a couple. The last thing we want to look at with wave interactions is the Doppler effect. So the Doppler effect, as a wave source approaches an object, the waves that it emits begin to catch up to one another, resulting in a shorter wavelength and higher frequency. So waves are emitted at a constant rate from a source. If that source is stationary, those waves maintain the same wavelength and frequency. But if the object is moving, then the waves begin to bunch up in front of the object and spread out behind the object. So this bunching up in the front of the object results in a shorter wavelength and higher frequency, which causes a blue shift in light, because blue has a shorter wavelength than the other colors do, and causes a higher pitch in sound. So if you have an ambulance pass by you while you're standing on the side of the road, or while you're pulled over on the side of the road because you moved to let it pass, it has a higher pitch after it, or as it approaches you, than after it passes by you. So the opposite side of the Doppler effect is that behind the object, the waves begin to spread out, and so they have a longer wavelength and a lower frequency, which results in a red shift in light waves and a lower pitch in sound waves. So again, things like the ambulance, the fire truck, the police car with their sirens on, those are very easy ones to identify because we deal with them in everyday life. But this red shift is actually what allows us to have some evidence of the Big Bang Theory, because most of the galaxies and everything that are around us are actually red shifted. So that gives us a big overview of our wave interactions and sums up the rest of our unit on waves.